It's day 15 of 50 days of tutelage, and we're having chemistry today. I'll be talking about chemical formula and equations. In the last class, I concluded the class on chemical bonding, and I had already explained to you how chemical bonds form. I explained the concept of ionic bond. I explained the concept of covalent bond as well. One involves losing electron and accepting electron, and the other one involves sharing electron between atoms. Of course, I discussed some other special ones as well, but those are the two major ones. So in today's class, we want to look at how when this whole process happens, losing electron, gaining electron, or sharing electrons, what happens is that we have formation of compounds and molecules, and these guys always have their formula. So how do we now determine the correct formula that is formed during any of such chemical processes? So before I proceed, I'm going to quickly write some ions in this place because I told you that in the last class that whenever they lose or gain electron, what they do is that they form ions. So I'm going to start with the ionic compounds first. So let's list out some common ions that we know. We have Na plus. There is also Ca2 plus. There is yes, Al3 plus. We have the negative ones as well. We have Cl minus. We have the O2 minus. I think I'm just going to limit it to that now. But apart from these ions, there are other guys that carry charges that I did not talk about in the last class. These guys are known as radicals. They are known as radicals. You know how that we said that when atoms come together and they do either sharing or gaining and losing electron, when they do any of these, they form a compound or a molecule. In the case of water, hydrogen and oxygen can come together and they become H2O. This is a molecule of water. So we have two atoms of hydrogen and one atom of oxygen. But the same hydrogen and oxygen, they can combine together to give this. In this situation, you can see that their combination is carrying a charge, a negative charge. Then this guy is regarded to as a radical. There are other guys too, like your SO4 2 minus. You also have your ammonium ion, NH4 plus as well. And then so many other ones. I'm just going to limit it to this for now. So let's see how do these guys combine? So what determines the formula of such compound? So which leads me to combining power. So there's something we call combining power, also known as valency. Combining power, also known as valency. Simply put, from the word valency, it shouldn't be strange to you anymore in this class. It's just the number of electrons that an atom would have in its outermost shell. So this is also their combining power. It shows what hold that they have on the electron that is in their outermost shell, and it shows how they can actually combine with other guys as well. This is very easy for ionic compound because what we just need to do is that we just need to look at them and say, okay, so let me say I want to pair this Ca2 plus and chlorine now. If I want to pair these two together, so I'm going to have Ca2 plus, I'm going to have Cl minus. In this case, these two will form an ionic compound, calcium chloride. So how do I now know which one we have the number of atoms that is different from the other, or we did have the same number of atoms and all of that? So this is the way that is done. We say this is like a combining power of 1. A combining power of 1. And this is like a combining power of 2. So what happened is that we switch the place of those guys. So if this one has a combining power of 2, then we're going to bring 2 for chlorine here. And if this has a combining power of 1, we're going to bring 1 to this. So what happened here is that the formation of these two guys to form a compound is going to be calcium, just one of them, and chlorine, 2 atoms of chlorine. So we have CaCl2. This compound now is an ionic compound. It has been formed by using 1 atom of calcium and 2 atoms of chlorine. So that is exactly what we're talking about here. So what if you have something of this nature? You have Ca2 plus and you have O2 minus. As you can see, both of them have the same combining power. This one has 2, this one has 2. Of course, they are different in sign, but I'm only concerned about the number. So this one has 2, this one has 2. If you had to do it by what I did here, you would have something like Ca2O2. But we don't really need these things. We need them in their simplest ratio. So therefore, you're going to have CaO. So this is what we are talking about. So that is exactly how combining power and all of this thing works. And with the radicals as well, it's also like the same thing. So let's say you have Na plus and you have SO4 2 minus. So how will this form? The entire SO4 2 minus is going to stand in just like you would treat a usual atom that is carrying a charge. So this is having a combining power of 1 and this is having a combining power of 2. So therefore, 1 is going to be for SO4 and then 2 is going to be for Na. So therefore, you have Na2, then you have SO4. By the way, how many atoms are here altogether? We have Na, that's 2 atoms, sulfur, that's 1 atom, and then that's 3 plus 4, so 7 atoms, but 1 mole of Na2SO4. Let's do one more before we leave and move to the next thing. So let's do aluminium, Al3 plus and OH minus. So how will this guy combine? So you have in this place you have combining power of 1. In this place you have combining power of 3. So that implies that this OH is going to have 3 and the aluminum is going to have 1. So what do you have? You have Al, just one of it. Now you have OH. A mistake you might make is that you just write AlOH3. But by this, you are saying that hydrogen is the one that has 3 atoms. Oxygen is only 1 here. So but because OH is a radical, you treat it as 1. So you put a parenthesis before you write the subscript. So that will be AlOH3. And that is how these guys combine. So I've shown you how they form compound, how they form molecules like that with their combining power. The similar thing is also what happens when it comes to covalent bond as well. For instance, you have your carbon and you have your hydrogen. In carbon, you know that carbon does not really form ion like that. It has how many electrons in its outermost shell? 4. And hydrogen has 1 electron in its outermost shell. So when they want to combine as well, they kind of combine in that similar way. So you have something like CH4. Of course, there might be variation. For covalent compound, there's always a possibility of them forming other compounds or other molecules that are different from just the usual one or the regular one that we know about. I'm trying to think of another another covalent compound now that can be formed. I think I'm going to come up with one very soon. Let's just continue with the class. So that is that. And there's something we call empirical formula. This empirical formula is basically the basic formula that a particular compound can have. That is what empirical formula is. It is the basic formula that a chemical compound can have. What we mean by basic is that, for instance, look at this CH4 now. If imagine you double the carbon and you double the hydrogen, so you are looking at C2H8 like that. You can also triple it, just say C3H12, and it can go on and on like that. But when you look at all of these all together, the simplest one of them is the CH4. So this CH4 is known as the empirical formula. Empirical formula rather. And then another example is, let's say you have this guy, CH2O. CH2O. You can actually multiply this thing by 6 and you have C6H12O6. This, you are familiar with it. I know this is glucose. So, but it has an empirical formula of CH2O. 1 atom of carbon, 2 atoms of hydrogen, and 1 atom of oxygen. So empirical formula is simply like a basic, the foundational formula that some chemical compounds have, especially chemical compounds that have the tendency of changing or becoming something else when their number of atoms increases. So that is empirical formula. So I'm going to teach you how to find empirical formula of a compound based on given information. So I'm going to start with I have a question here that I want us to look at together. I'm just going to paste that right here. The question says, the question says calculate the empirical formula of a compound contain, containing 43% containing 43.4% sodium, 11.3% carbon, and 45.3% oxygen. And we've been given the mass number of each of these guys. So what we need to do is that we need to write it out, everything. We have sodium, we have oxygen, carbon, and we have oxygen. So the next thing we do here is that we try to write their percentages under them. So this was given as 43.4%, and this was given as 11.3%, and this was given as 45.3%. I will just ignore the percentage. The next thing we do is that we look at the mass number of each of these, their RAM, relative atomic mass, then we divide whatever this percentage by mass is, we divide it by each of the relative atomic mass. So for sodium, it's 23. So we divide this by 23. For oxygen, it is 6. For carbon, it is 12. So we divide this by 12. For oxygen, it is 16. We divide this by 16. So let's do that. 43.4 divided by 23. That's 1.887. It's good to leave it at least 3 decimal places to get a better result for this kind of computation. 11.3 divided by 12. 11.3 divided by 12 is 0.942. And finally, we have 45.3 divided by 16. That's 2.831. So when you have gotten this, that is, you have been able to get more like their number of moles, how they combine in each, or how each of them combine in the particular compound that is formed. Then you look at the smallest value among all of them. Which of them has the smallest value? You can see that is 0.942, which belongs to carbon. So you divide every single thing here by that smallest value. So divide this one by 0.942, divide it by 0.942, and divide this by 0.942. So what do you have at the end of the day? 1.887 divided by 0.942. So that's 2.003. Then this one is going to be 1. So 2.831 divided by 0.942. That is 3.005. So after having this now, we can actually approximate, because you can see that these numbers are so close to, like this one is so close to 2, this one is exactly 1, and this one is so close to 3. However, it's not every time that we approximate. When you begin to have, now, when you have 2.0 something, yes, you are free to approximate. Or you have, let's say, 2.1. So anything 0.1, you can maybe approximate. Or you have, let's say, 1.9, you can easily approximate to 2. But if you have like 2.2, 2.3, you need to be careful. You don't just approximate in that situation. So for this now, that means that the compound, the empirical formula for this compound is going to be Na2C1, but we don't need to write the C, Na2CO3. Now quickly, this is actually a formation of an ionic compound, but of course it has the covalent property based on this radical that is present here between carbon and oxygen. But like, there's also this ionic thing about Na. So we have Na and we have CO3. So based on what I've explained to you earlier, you can determine the charge that each of these would have. Of course, naturally, you know that Na would have Na+. But based on what you are seeing here, CO3 is a radical. So what charge is it going to have? If you want to try that, you can pause the video at this moment and try that. Okay, so this is what it's going to have. So you can see that this is CO3. There's no bracket that is putting anything as a subscript. So therefore, whatever the subscript is going to be here is 1. So therefore, sodium has the plus 1. And sodium has the 2 here at the base. That means that it must have gotten the 2 from the combining power of CO3. So that will be CO3 2 minus. And so this is such compound. And that's what empirical formula is. Now there's also molecular formula, that is determining the exact formula of a given compound or of a given molecule. Determining the exact formula. We do it almost the same way that we do this hydrocarbon thing as well. So let's quickly take that example. Finding molecular formula. Finding molecular formula. So let's quickly answer this question. It says a certain hydrocarbon contains 80%. So when you hear hydrocarbon, you're talking about carbon and hydrogen. So there is carbon, there is hydrogen. 80% by carbon, so that's 80 by mass. If its relative atomic mass is 30, now we have been given the relative atomic mass of the hydrocarbon is 30. 80% by mass, what is its molecular formula? Now, since it is an hydrocarbon, it contains carbon and hydrogen. So therefore, we know that carbon is 80%. Therefore, hydrogen is going to be 20%. That is just, total is going to be 100%. So you divide each of these guys by the atomic mass of, so for carbon is 12, for hydrogen is 1. So when you do 80 divided by 12, 80 divided by 12, that's 6.667. And then this 20 divided by 1, that's 20. So you divide each by 6.667. 6.667. So this is going to be 1. And 20 divided by 6.667, this is going to be exactly approximately 3. So in that situation, what we're going to have there is going to be CH3. What we're going to have here is going to be CH3. So if this is CH3, and we're told that the atomic relative molecular mass of this is 30. So therefore, find the actual formula. So all we have to do is that in this place we place N outside, and then we try to equate this to 30. So carbon is 12 plus hydrogen is 1, but we have 3 of it there, so that's 1 times 3. So everything multiplied by N equals 30. So here we have 12 plus 3, that's going to be 15N equals 30. So that means that N equals 30 divided by 15, which is 2. So what does that imply? That implies that I'm going to have CH3, then there's going to be 2 outside. So the 2 can go inside and multiply each of the atoms. So carbon will now be 2, C2, hydrogen will now be what? 6, 2 times 3, and that is what? C2H6. And that is going to be the molecular formula of that compound. So now you know how we move from empirical formula to molecular formula. So that is that. Now I want to talk about something else, which is balancing of chemical equations. Balancing of chemical equations. I'm sure you're familiar with some balancing of chemical equations. You can just balance by inspection, by looking at something. For instance, if hydrogen should combine, hydrogen is diatomic. Oxygen is also diatomic as well. So when they combine together, they form water. In most cases, they form water. Now, how do we balance this equation? You can see that hydrogen here we have 2, hydrogen here we have 2. So that means that is already balanced. We balance actually only by adding numbers to the to before them, which is like only by number of moles. So we can only balance by putting numbers here. You cannot just change this and say, oh, I have 2 oxygens here, I have 1 oxygen here, so therefore I want to put a 2 here. You won't be able to do that. So the only place where you can put a 2 is behind this. And when you put a 2 behind this, it affects everything that is in question. So for instance, hydrogen, we have 2 here. We have 2 hydrogen atoms here. That is balanced. So from left and right hand side. Of course, I know I don't want to go into too much detail about talking about reactant side and product side. I will explain that better when I'm dealing with mole concepts and all of that. So let's focus on balancing chemical equations here. So the left hand side must be balanced with the right hand side. So 2 atoms of hydrogen, two atoms of hydrogen. But how many atoms of hydrogen do I have on the left? Two atoms. How many atoms of oxygen do I have on the right? That's just one atom. So therefore, I need it to be 2. I can multiply this with 2. And that sort of balances the oxygen. So I have 2 atoms of oxygen here, then 2 atoms of oxygen on the left. But the hydrogen that was balanced initially, this is now 4, this is now 2. What can I do again? I need to put a 2 here. So when I put 2 here, everything becomes balanced. So quickly, let's get into it. What if we have a difficult one? A difficult one such that it doesn't just really play out like that. So let's say we have a compound like this. So we have this chemical equation. We have this plus CaCl2, and this gives LiCl plus Ca3PO42. So you have this now, and we want to balance this equation actually. So how do we go about that? So let's try to do it by inspection. Then I will teach you a way to actually always get it. So if we want to go by inspection, let's start with lithium. Lithium here is 3 and lithium here is 1. So it makes sense if I just say, let me put 3 here. I think I should move this forward a little bit. No. Yeah, so lithium here is now 3. So we assume that that is balanced. Let's go for the next guy here, which is phosphorus. Phosphorus here is 1. Phosphorus here is 2 actually, because there is 1 inside. Let me write that place properly. Ca3, then you have PO42. Now, inside the parentheses, phosphorus is 1 atom, but because of the 2 outside, the 2 is affecting both phosphorus and oxygen. So what we're going to have here is going to be 2 atoms of phosphorus, but we only have 1 atom of phosphorus here. Unfortunately, when you want to balance that, because you have 2 here, so you want to multiply this one by 2, it affects the lithium as well. Lithium that was balanced before by using this 3 is now 2 times 3, which is 6. So therefore, what do we have to put here? What we have to put here is 6. Now, lithium and phosphorus, they are balanced. I don't want us to balance oxygen yet. In most cases, you should always leave oxygen and hydrogen as the last thing that you balance. So let's go for calcium. Calcium is 1 here and it is 3 here. 3 atoms here, 1 atom here. So to balance it, we can put a 3 here. So calcium is balanced. Now let's look at chlorine. Chlorine is 3 times 2 is 6 here. And then we also have 6 here. Like I said, the number behind now always affects everything in that place. So it affects lithium, it affects chlorine. So it seems lithium balanced, phosphorus is balanced, calcium is balanced, chlorine is balanced. The only thing we have left is oxygen. And then I hope we are lucky enough that oxygen is balanced in that same process as well. So oxygen inside here, we have 4 of it. Then we have 2 here, so that will be 4 times 2, that's 8. And here we have 4 oxygen here, so 2 times 4, that is also 8. So with that, that makes oxygen balance as well. And this is actually how you balance a chemical equation. So you can balance it by inspection. But there's also another way you can go about it, which is a method of simultaneous equation. That is in another video, which I'm going to add the link. So you can see the link pop up right away. You can check the link out to see the simultaneous equation, because there are some equations that you will not be able to balance using the method of inspection, or perhaps it will take you a long period of time before you can get to figure it out. So you can just go the surest way, which is using the simultaneous equation method. You can see the link already, so just check the video out and then you would be able to get the proper way to go about it. And that's going to be it for today's class on chemical formula and equations. If you have not subscribed to the channel, you should do that, and engage and share the video with your friends as well. I'll see you in the next one.